Video Manuals offers a series of videos on highway mechanics for bike enthusiasts. This video presents the Evolution motors disassembly and reassembly. This engine is the latest style to come from the States. Fondly known as the Evo motor or the Evolution, this type of motor arrived in Australia in about 1984. It still retains the basic bottom end shape of the older style motors, including the gear case cover or cone, on this the cone side of the motor. On the other side, which is the primary side, is the primary drive assembly, behind which is the charging system. When the motor rotates anti-clockwise, it drives via a chain the clutch assembly and gearbox. Let's now commence our disassembly. To strip the motor, firstly, we remove the top engine mounting bracket using a 9/16 ring spanner. We find two wires attached to the VOES, or vacuum operated electronic switch. This switch advances and retards the timing at low engine revs. One of these wires is the earth. The other connects to the electronic ignition module. In most cases, the choke will also be attached to this bracket. Removing the choke and switch from the bracket is time-consuming and often unnecessary, so we'll just let them hang over the carby. We remove the carby with a 1/4 inch Allen key wrench by loosening the 4 Allen head bolts holding the intake manifold to the heads. We only need to remove 2 of these bolts, as the manifold flange has 2 holes and 2 slots for ease of maintenance and installation. When we've removed these 2 bolts, the carby, the intake manifold and top engine mount can be removed as one unit. By the way, this is a relatively new type of carburetor for Harleys. It's called a constant velocity, or CV carby for short. Our next step is to undo and remove the 4 Allen bolts from the top cover of each rocker box using a 3/16 Allen key wrench. Each bolt has a metal washer and fibre washer. We can then proceed to lift the cover off, complete with bolts in place. Beneath this cover we find a second cover. These covers will sometimes come off as a single unit if the seals have been baked from the heat of the motor. We now have exposed the lower cover's rocker assembly. To remove the rockers, we should first raise the front cylinder to the top dead centre of its compression stroke. To do this, we need first to remove the 2 spark plugs by using a spark plug spanner or a 13/16 ring spanner. With an Allen key wrench, we now remove the timing inspection plug. Through this hole we can see the left-hand flywheel and the timing marks for each cylinder. For better leverage, we loosen the sprocket shaft nut and remove it with the spacer. We then turn the rotor around to gain more grip to turn the motor. By rotating the motor anti-clockwise and using our thumb to cover the front cylinder's spark plug hole, we can feel air being forced past our thumb. This means the front cylinder's piston is rising to the top of its compression stroke. We then look into the timing hole and watch for the long timing mark. With this mark in the centre of the hole, the piston is now at the top of its compression stroke, or top dead centre. There should be very little pressure on the rocker arms, though there is no clearance. If you like, you can rotate the engine again and watch what happens to the rockers. You'll notice the push rods and rockers working to open the valves, but don't forget to put the front piston back to its top dead centre as shown. You'll also notice that the front inlet rocker is the last to rise and finally fall. This is true of all 4-stroke engines. We need to mark each rocker arm and shaft so that when it comes to reassembly, we'll be able to replace each set correctly. We mark one rocker arm, front inlet or FI, and the other front exhaust or FE. Across the inlet shaft, we draw a horizontal line like so, and for the exhaust, a plus or cross, making sure the marks go across each rod and onto their corresponding journals. Working now over the top of the motor, we first loosen the 2 Allen bolts. Then, using an extension bar, we loosen the 3 7/16 bolts. We undo the smaller bolts first because the larger bolts are best able to maintain the tension on the rocker. Next we undo the 4 half-inch bolts. We do this using a cross pattern method. We loosen them a quarter turn at a time. This method of undoing the bolts prevents us warping the lower rocker cover. The next step is to remove the 2 half-inch bolts on the cone side. These act as cotter pins to hold the shafts in place. They also stop them rotating. Once removed, we use a soft metal drift and push the shafts through from the primary side. As each shaft is removed, collect its matching rocker. The push rods can now be removed, and we place them in the storage cards we've prepared. The cards are marked front and rear. There are 2 holes in each card to accommodate the inlet and exhaust push rods. These parts have been computer matched and must be replaced exactly as removed. In most cases, the push rods have a colour coding system painted at the top which assists us to correctly replace them. The front inlet push rod is yellow, while the front exhaust rod is green. Leaving all the loosened bolts in place, we simply lift the base rocker cover plate off, along with its gasket. With a twisting motion, we remove the push rod cover's retaining clip with a screwdriver. We then twist the remaining pushrod cover, lifting at the same time to break the seal. Pushrod covers can at times be difficult to remove and may require considerable force. The other pushrod cover on the front cylinder is removed in exactly the same way. This of course also applies to the pushrod covers on the rear cylinder. We now remove the O-rings from the pushrod recesses in the head. These O-rings seal the top section. We also remove the O-rings and the steel washers from the tappet guide holes in the tappet block. The pushrod covers are telescopic. To dismantle them, we pull the top out, hold and push the retaining cap down. Under this cap we have a spring, a flat washer and then an O-ring. By simply pulling the top out, the O-ring can be removed. As we can see, there are 2 valves either side of the head, the inlet valve and the exhaust valve. To remove them, we must first remove the head. This is done by loosening these 4 bolts. These bolts must be undone in a sequence as shown on this card, and must be done in stages. That is, 1/8 of a turn for each bolt in sequence. Failure to follow this procedure could cause the cylinder head and barrel to warp, so we need to take it slowly. Only when the pressure is completely off these head bolts can we unscrew them by hand. We'll leave them in place. A short sharp hit with the palm will break the carbon seal and the head gasket. Carefully lift off the head with its head bolts. Beneath the head we can see the 2 valve heads. Notice the shape of the combustion chamber. This solid section dramatically increases the compression of the fuel-air mixture, enabling an efficient combustion pattern, as well as increasing the velocity of the exhaust gases. We now remove the head gasket. This of course could have been stuck on the barrel. Notice also the offset pattern of the pushrod holes. This straightens the pushrod's working angle, increasing the life of the tappets and the pushrod assemblies. Before we remove the front barrel, we mark the piston together with the barrel to aid in reassembly. We again check that the front piston is at the top of its travel. Taking a firm hold of the barrel, we gently rock it to break the seal. Once the seal is broken, we carefully raise it. Once it is free from the crankcase, we insert a rag around the conrod and cover the crankcase hole. This rag stops any carbon, dirt or cracked rings falling into the crankcase. We then continue to raise the barrel until the piston is almost out. Then, with our hand under the cylinder, steadying the piston to stop it hitting the cylinder studs, we can completely remove the cylinder. We then rest the piston carefully against the studs. To protect the studs and the pistons when resting against each other, we'll need to slide 4 pieces of 1/2-inch rubber tubing over the cylinder studs. As you can see, this tubing has been cut from common old garden hose. The piston can now rest safely against the studs. When working on the piston and its components, safety glasses must be worn. At the top of the piston, we have the piston ring assembly. Directly beneath the rings is the piston or gudgeon pin. Working from the top, we see the top compression ring. Next is the second compression ring. The lower set of rings comprises 2 thin oil scraper rings, separated by a segmented or spreader ring. This last set are used as oil control rings. To remove the rings, we spread the top ring, placing one edge over the top of the piston and rotating until the ring slips off. We must be careful not to scratch the piston or burr their landings. The second ring and the oil control rings are removed in a similar fashion. The best results are achieved by removing the remaining rings one landing at a time. To remove the piston pin or gudgeon pin retaining clip, we insert a probe. We lift and lever the clip out of its groove and over the edge of the piston pin's journal. We must be careful not to damage the piston skirt. The clip on the other side is removed in exactly the same way. Removing the gudgeon pin requires some effort. At no time should it be hammered out, however. Such force could damage the conrod and its bearings. If necessary, warm the piston to remove the gudgeon pin. Push the gudgeon pin through the primary side until it clears the conrod assembly. We can now lift the piston and remove it. There's often an arrow cast into the piston top. Depending on the model, a cast nib or stroke can be seen underneath. This nib would normally face to the left or the primary side. Before we can remove the tappet blocks, we must first disassemble the rear cylinder. We should rotate the engine until the rear piston is at its top dead center. With our thumb placed over the rear head spark plug hole, we feel for escaping air. Through the timing hole, we can observe the dot, which indicates the rear cylinder's top dead center. We can now remove the rear cylinder in exactly the same way we disassembled the front cylinder. To remove the tappet block, we need first to undo the 4 1/4-inch bolts using a multi-hex socket. We then remove them. With a large paper clip bent to this shape, insert it into the oil holes of the tappets. Holding the wire back, we tilt the tappet block to break the gasket seal and remove it, complete with the hydraulic units and cam followers. Each unit must go back into its original bore, so store them in a box or container clearly marked and cover them with a rag to protect them. Once the outer cover and rivets are removed, we undo the 2 inner cover screws with a Phillips head screwdriver and remove them along with the inner cover and gasket. This exposes the sensor plate screws. With a flat blade screwdriver, remove these also. Then, by feeding through some of the sensor's wiring harness, the sensor plate simply leans back. The sensor plate normally stays with the cone because of the plug attached to the other end of its wiring harness. Next, we remove the rotor. With a 5/16 socket, we can undo the rotor's retaining nut. We then remove it. Once it's out, we're then in a position to remove the rotor. With an old gasket at hand, we then loosen evenly the 6 Allen head bolts holding the gear case cone in place. As we extract each bolt, place it in the old gasket's corresponding hole. This is a good way of keeping all the bolts together and in their original positions. We now remove the cone by pulling from the outside while pushing from the inside with our fingers. The cam, which is behind the cone, may decide to come away with the cone, so as a precaution we hold it back with our fingers. Let's now describe the various components of the gear case. The large gear is the cam. The gear immediately below it is the crank pinion gear, which drives the cam. The gear to the left is the engine breather gear. On the breather should be a spacer. If it isn't on the breather, check the cone face. Many hours have been lost searching for breather spacers which are simply stuck by oil to the cone's face. Now we remove the gear case gasket. This gasket, of course, will need to be replaced. Notice that the cam gear has a coloured paint dot, as has the pinion gear. When replacing either of these gears, replace them with gears of the same colour, as these gears are matched. We now remove the cam, which comes out easily. It's a good idea at this stage to check the cam lobes for pitting. If we find any, the cam needs to be replaced. When selecting a different cam, be sure to use parts made for this motor type. Later model cams are identified by the two circles on its gear face. On earlier models, there is usually a thrust washer and a shim. Let's now remove the breather, which can be made of either plastic or steel. To pull the oil pump apart, we'll need to loosen all bolts and remove the three holding the outer cover to the body, leaving the remaining bolt to hold the case in position. Once the case is removed, the remaining bolt and gasket may also be removed. We then take the circlip off the end of the drive shaft using a probe. This circlip should be discarded. The drive gear then slides off the drive shaft. It can carefully be levered from behind. This gear has a keyway. It's the keyway that interlocks with the woodruff key and the pump's drive shaft, enabling the gear to be driven. We then remove the woodruff key itself. The idler gear, which is driven by the keyed gear, is the next part to be removed. It simply slides off. Note this front set of gears supplies the pressurized oil to the motor. The pump body is now ready to be removed. We first remove the two remaining bolts. Placing the thumb over the shaft for leverage, we can now pull the pump body off the shaft, along with its gasket. Once removed, we can see the other drive and idler gears, which should also be removed. This set of gears returns oil to the oil tank and are often called scavenger pump or oil return gears. The remaining gear can now be removed. It simply slides off. Notice it too has a keyway. It's from this keyway we take out the woodruff key with our pliers. Working now from inside the gear case and holding back this gear, we can push the main shaft of the oil pump through to expose a circlip at the end. This circlip holds the woodruff key in its keyway and holds the gear on the end of the shaft. Removing it with circlip pliers is a fiddly job. Once removed, this circlip should be discarded. With the circlip removed, the main shaft can be pushed back through the gear and removed from the gear case. It simply slides out. The remaining key could either be in the pump drive gear or may have fallen to the bottom of the gear case. Either way, it can be retrieved when retrieving the pump drive gear. The next thing we need to do is to dismantle the pump body. We use a large flat blade screwdriver to loosen the relief valve and, of course, the check valve. The relief valve plug can now be removed by hand. It will reveal the spring inside. The relief valve plug has an O-ring on it, which should be replaced. As well as pulling out the spring, we'll need to remove the plunger. More often than not, the plunger will not be attached to the spring, and some effort may be required to retrieve it. Next, we remove the check valve plug. It too has an O-ring, which will need to be replaced. Remove the spring and then roll out the ball valve. This ball valve prevents the engine oil running back into the engine from the oil tank. To complete the dismantling of the oil pump, we'll need to remove the remaining seal. Using a probe, we can push the seal out. This seal will also need to be replaced. Once again, using a screwdriver, we'll remove the tappet screen plug from the top of the gear case. It also has an O-ring that needs to be replaced. Next, we can fish out the spring and oil screen. The screen actually sits beneath the spring. Because we've previously turned the rotor around, we simply slide it off. Next, we remove the washer. This too slides off. Now remove the 4 bolts with a Torx key. With a Phillips head screwdriver, we can now remove the screws holding the nylon retaining bracket. This too can be removed. The stator, which may be difficult to remove, is slipped off and rested on the shaft. With a blunt instrument, push the plug back into the motor. Once this is free, remove the stator. To split the cases, we must first remove all the nuts and bolts holding them together, all except the bolts in this configuration. The one at the top center, the one at the bottom left-hand side of the screen, and on the bottom right of the screen. If we need to drive them through with a drift, we can do this from the gear case side. We'll place them in the corresponding holes in the card. Remember, these bolts hold the cases in the correct alignment. Mix them and we could misalign the crankcases. After we remove the rags, we can pull the case. The cases should split, exposing the crank. Do not use the cylinder studs to pull the cases apart. If these bend or are damaged, they'll have to be replaced. What we're looking at now is a 3-piece crank with the conrods intact. The 3 pieces comprise the pinion shaft and right flywheel, the left flywheel and primary shaft, and the crank pin here holding the conrods. On the crank's pinion shaft, we have, starting from the end, the pinion gear which drives the cam. Next we have a spacer, then the oil pump gear or oil pinion gear. These are the main crank bearings for this side of the motor. All these parts are driven via metal keys. The pinion nut, which locks these parts onto the shaft, has a left-hand thread and is tightened to 40 foot-pounds torque. Looking at the conrod journals or big ends, we see what is called a knife and fork bottom end, which is unique to this brand of motor. The whole crank will need to be pressed out from the remaining case when being serviced. We recommend taking the complete crank as is to a reputable workshop for any further servicing. We first remove the 4 head bolts. There's 2 large and 2 small. To remove the valves, we'll need a valve spring compressor. Place the splayed end over the top of the valve stem. The other end of the compressor is placed over the head of the valve like so. We then compress. This process is not easy because we're tensioning the springs. We'll need to keep winding until the spring tension is taken off the valve collets. If we're lucky, they might fall out like this one. If not, we'll need to apply further pressure until we can pry the collet out. Collets hold the spring assembly in place. Be careful not to lose these collets. We must keep them together, as the collets are a matched pair and must go on back together later. Once the collets are removed, we release the tension on the springs by undoing the spring compressor. We can now remove the valve spring's top retainer washer. We then remove the dual springs, which consists of one inner spring and one outer spring. These springs return the valve to the closed position after the valve has been pushed open. Before we attempt to remove the valves, however, it's good practice to first check the groove at the top of the valve stem for any burrs caused by the valve collets. If there are any present, we'll need to carefully file them off before removal. To remove the valve, we push the valve stem through the valve guide. We may in fact have to apply some pressure to force the valves past the guide seal because of the sharp edge on the valve stem. This seal is destroyed in the process. The other valve is disassembled in exactly the same way. We can now remove the valve stem seals. Generally, however, some effort is required to remove them from the valve guides. We're using a pair of multi-grips to assist us. We also need to remove the base washers. The valve guides hold the valves true to their seats and are also serviceable. We recommend that all work done on the valve guides and seats seen here be done at a reputable workshop. Valve facing and reseating or synchro seating requires specialized tooling. The inlet and exhaust valves and seats are easily identifiable, but to ensure that valves from the front and rear cylinders do not get mixed up, we can keep them separated and identified by placing them in cards like this. We have now completed the disassembly of our Evo motor. We must now clean thoroughly all the parts, paying particular attention to gasket surfaces. Before putting the crankcase back together, we must oil all bearings and their surfaces. We must also clean the mating surfaces and use a good quality sealant, as there is no gasket between the two crankcases. Carefully slip the right side of the crankcase over the pinion shaft. Taking the 3 studs we placed in our reference card earlier, we insert them into their corresponding holes. Observing from the primary side, these 2 bolts, along with all other studs, are tightened with a torque wrench to 18 foot-pounds. Firstly, the oil pump's main shaft should be free of deep wear marks. The keyway edges should also be square. We insert the oil pump drive shaft with its 3 keyways, 1 key to the inside while the other 2 remain outside. We now insert and mesh the pump's drive gear with the worm gear on the pinion shaft. This is a fiddly exercise, so pay particular attention to the angle of the keyways seen here. We have found this position is the easiest to insert the woodruff keys later. The drive gear keyway should correspond with this angle. We'll need to push the shaft through the gear to expose the end keyway. We can then insert the woodruff key, which is also a delicate procedure. Once the key is in place, we push the shaft partly into the gear. There are 2 pairs of gears still to be installed, 1 small pair and 1 large pair. We now replace the woodruff key on the shaft. Selecting a large gear with a keyway, we slide it into place over the woodruff key. It shouldn't rotate on the shaft if we've placed it properly. To reassemble the oil pump, first we replace the pump's main shaft seal. We push it home with a socket until it sits snugly, with its sealing lip facing in. We then replace the check valve bore. This is followed by the fine spring. We then replace the check valve cap with its new O-ring and screw it down by hand. We can now replace the pressure relief piston, making sure that the hollow end is at the top. Insert the coarse spring, and then replace the cap with its new O-ring. Once both the check valve and relief valve have been tightened by hand, we'll need to tighten them with a screwdriver. We now replace the remaining large idler gear onto its shaft and the pump body. We then push 2 7/16 bolts into the top and place the body gasket over them. The pump body is now ready to be installed on the gear case. Holding back the pump's main shaft, we slide the pump body over the shaft. When the gears mesh, it will sit up against the crankcase wall. We finger tighten the top 2 pump body bolts. We then insert the next woodruff key onto the main shaft and place the drive gear on the shaft and over the key. If installed correctly, the gear shouldn't rotate. The next gear to go on is the idler gear. It simply slips onto this shaft. We need now to secure the drive gear by replacing the circlip. Of course, this circlip is brand new. To replace the oil pump outer cover, we first replace the gasket and the two inside bolts, pulling their washers back against their heads. We do this to make room for the oil pump outer cover. We then slip the outer cover on and insert the other two bolts. But before we torque down the 6 mounting bolts, we must ensure that the oil pump body clears the face of the case, like so. With our torque wrench, we tighten all the bolts to 9 foot-pounds. Next, we place a new circlip on the end of the shaft inside the gear case. This circlip holds the drive gear and key in place. We then replace the tappet's oil screen. In goes the screen, followed by the spring. And then finally, the oil cap, with its new O-ring. We first place a new cone gasket on the locating dowels at the top and bottom centre of the cone. Then we replace the breather gear, followed by its spacer, making sure that the tapered inside bore of the spacer is facing towards the breather. We now check the end float on the breather gear. We do this by placing our straight edge across the face of the cone gasket and over the breather's spacer and inserting our feeler gauge. If there's no clearance between the spacer and straight edge, then the spacer is too thick. There's a range of spacers available with varying thicknesses, approximate increments being 3 thou. We then select a thinner spacer until there is clearance between the spacer and the straight edge. Having reached this stage, we measure the clearance with a set of feeler gauges. If the resulting clearance is between 7 and 16 thou, then the spacer is correct. This tolerance allows for the cone gasket's compression when the cone is being torqued down. We now temporarily remove the cone gasket and spacer and breather to allow room to insert and manoeuvre the cam. But before inserting the cam, we place the winged thrust washer in position and rotate the motor until the timing mark on the pinion gear is at 12 o'clock. Aligning the timing mark on the cam with the timing mark on the pinion gear, we manoeuvre the cam into position. Once in position and with the timing marks aligned, we reinsert the oil breather, ensuring that its timing mark aligns with the corresponding timing mark on the cam. It is essential that all timing marks are aligned in this configuration, otherwise the valves may collide with the pistons. Severe crankcase pressure could also result. We again insert the breather's spacer, ensuring it goes on as before. Replacing the cone gasket, we are now in a position to replace the cone. It is important, however, before replacing the cone that we replace the cam seal. This is normally punched out with a flat-nosed punch from the inside of the cone. By feeling and locating the cam seal with our punch and using a light hammer, we drive the old cam seal out, being careful not to damage the seal housing in the cone. We then place the new cam seal in its recess with the tension spring facing the flywheel. Selecting a socket large enough to cover the cam seal, yet small enough to go into the cam seal recess, we punch the new cam seal back in, being careful not to deform our new seal or damage the seal's recess. With the new cam seal in place, we can now install the cone on the two locating dowels on the gear case. We then take our 6 Allen head bolts from our old storage gasket and insert them. All 6 bolts should be torqued down to 10 foot-pounds. Once all the bolts are torqued down correctly, we then check the cam end float through the tappet block holes. Using a feeler gauge, we measure the clearance between the thrust washer and the end of the cam. The tolerance for this clearance is 1 to 50 thou. Earlier models have a shim between the thrust washer and cam. Their tolerance is 1 to 16 thou. It is also advisable to again check that the breather has visible end float. If the end float on the cam is not within tolerance or there is no end float on the breather, the whole procedure will have to be repeated. Before replacing the tappet block guides, we need firstly to check the cam followers and their guides for correct tolerances with a set of verniers. Firstly, we measure the tappet or cam follower's outside diameter. Then we measure the inside diameter of its matching guide. If the clearance is more than 3 thou, both should be replaced. it's important we keep all cam follower units in their original positions. Let's take a closer look at one of the hydraulic units, but before we pull it apart we'll need to wear safety glasses. To remove the spring clip, we use a set of long nose pliers. Place the nose of the pliers over one of the clip ends. While keeping our finger over the opposite end of the clip, we lift the clip end over the edge with the pliers. We do the same for the other leg. Removing this clip releases the inner piston. On the underside of this piston, we find a spring. We simply pull it away. Tipping up the unit, we remove a small round plate with 4 holes and also a small metal cup. The push rod sits in this cup. Oil is pumped through this hole in the unit's base, past the plate, through the cup and up the hollow push rod. Where the spring was seated is a small valve. This valve lets oil pass, creating an oil or hydraulic cushion that will take up any free play on the push rod. We can check its function by firstly cleaning the unit, then blowing air through it. If we can suck air back through the valve, which simulates the action of the oil, the valve is faulty and should be replaced. Once tested, we can then proceed to reassemble the unit by placing the spring on the hydraulic piston. We then insert both the piston and spring into the cam follower. Pushing the piston down, we then push a piece of soft wire into the valve to release the airlock. We then replace the oil restrictor plate, followed by the push rod cup. Now for the tricky part. We compress the whole unit into the cam follower until we can slip the back of the retainer clip into the groove machined into the top of the cam follower. With our finger, we hold the clip in place, while we use the long nose pliers to replace the clip's arms. This method may require several attempts. The other 3 hydraulic units are disassembled and reassembled in the same manner. When replacing the tappet blocks, we use a reliable sealing compound on all gasket surfaces. We check to make sure the gasket holes are aligned. This is important as these are the only oil feeds for the rocker boxes. We then insert our paper clip to hold our cam followers in place. We can now install our tappet block into the front recess. Once correctly in place, we insert the 4 mounting bolts and torque them down to 10 foot-pounds using a cross-pattern method. The rear tappet block is installed in exactly the same way. We start by checking the tolerance between the gudgeon bush or piston pin bush and the gudgeon pin. If the clearance between the gudgeon bush and the gudgeon pin exceeds 1 thou, or these components are pitted or scored, then these parts need to be replaced. When fitting new pistons and gudgeons, we normally change the bush as well. The piston rings are checked by placing each ring into its respective cylinder. Using the bore's matching piston, slide it up the cylinder towards the top. To square the ring, we now push the ring against the piston, then slide the piston back. We then place a feeler gauge blade into the ring gap and keep changing the blade's thickness until it eventually moves back and forth through the ring gap with only a slight resistance. We again check that the ring is still square in the bore by pushing the piston back up the cylinder. If we get the same gap reading with our gauge, then we confirm the gap size. The gap for new compression rings should be between 7 and 20 thou. All ring gaps should be between 9 and 52 thou. All the rings to be used in the cylinder's bore, except the segmented ring, are measured in the same manner. We do, however, need to check the segmented ring in the bore to ensure its ends don't overlap. After sizing, these rings remain a matched set for this particular bore. The tolerance of the piston fit in the bore should be between a half thou to 1 3/4 thou when new. But because of the piston's complex shape, that is oval from front to rear and barrel shape from top to bottom, the piston diameter will be hard to measure normally. Before measuring or machining the barrel, it should be tightened between torque plates. Otherwise, bore measurements may vary by as much as 1 thou and may later lead to piston seizure. As boring requires such precise tolerances, we suggest taking all parts to a workshop geared for such work. We can allow up to 5.5 thou clearance between the piston and bore before having to change the piston and reboring the barrel. Once satisfied that the piston and bore tolerances are correct, we remove the piston from the barrel. Before replacing the cylinder, we should ensure that its top and base are flat. We check this by laying a straight edge across the top of the cylinder, firstly in a square pattern and then in a crisscross pattern. We can allow a warpage of no more than 8 thou and can measure this with our feeler gauges. We then check the base of the barrel. We allow no more than 6 thou warpage here. If these tolerances are exceeded, we need to replace the offending barrel. We're now ready to replace the rings. Of course, safety glasses should be worn while fitting the rings and circlips. First, the segmented ring is placed onto the third groove, followed by its 2 oil scraper rings, which sit either side of the segmented ring. Next, the second compression ring, which is easily recognized by the dot near the gap. This dot usually faces the top of the piston when installed. We work this ring into the second groove, climbing 1 ring landing at a time, being careful not to scratch the piston or overstretch the ring. We now replace the remaining compression ring. It slots into the top ring landing. We recommend that all replacement rings be brand new. We can now install the gudgeon pin by pushing it partially into the gudgeon's journal. Check that our piston has a pre-marked position so that it will face the correct way. If marked, the arrow goes to the front. If there is a nib underneath, it faces the left hand or primary side when seating correctly. It may be necessary to warm the piston to insert the gudgeon pin, if in fact it doesn't go in easily. After oiling the gudgeon bush and evenly spreading the oil, we can place the piston over its correct conrod. Locating the bearing with the gudgeon pin, we push it all the way through. We should now check each side of the piston's gudgeon pin to ensure the grooves have enough clearance for the retaining clips to be installed and are free from burrs and foreign objects. If all is okay, we are now ready to install the retaining clips, but first we must place a rag over the crankcase hole to catch the gudgeon clips should they fall. It would be a shame to have to pull the whole motor down again just to retrieve one little retaining clip. To install the retaining clips, turn the gaps to the side. Using a small screwdriver, insert it into the recess and lever up. At the same time, we push in with our fingers. Always use new clips to avoid damage during engine operation. There are 2 clips per piston. Be sure to install both. Using a reliable sealing compound on both sides of the base gasket, place it onto the barrel base, ensuring all holes line up. We smear oil into the bore from top to bottom. Next, oil the rings and their grooves or landings, turning the rings to ensure even penetration of the oil. Starting with the compression rings, we stagger the gaps to the opposite sides of the piston. That is the 9 o'clock and 3 o'clock positions. The oil scrapers gaps are staggered to the 12 o'clock and 6 o'clock positions. Next, we remove the protective hoses, being careful the piston doesn't fall onto the studs. We're now ready to apply our ring compressor. We slip our ring compressor over the piston and rings and tighten it, but not too tightly because we need it to slide down the piston when we're installing the barrel over the rings. Then again, not so loose that the rings won't slide into the barrel. We also need to leave a leading edge at the top of our piston, here, to help start the barrel over the piston. We then insert 2 pieces of wood over the rag under the piston and lower the piston onto these blocks. To correctly position the barrel over the studs, we align this locating hole on the barrel with the locating dowel on the crankcase. We then guide the barrel gently over the piston, checking that the rings are in fact going in and not catching on the barrel. With the palm of our hand, tap the barrel over the rings. When the barrel is far enough down the piston, we can release the ring compressor and remove it, being careful not to drop the barrel. Once the ring compressor is removed, tap the barrel down even further and remove the 2 blocks, then the rag. While holding up the barrel, we make a final check of the crankcase barrel surface and remove any oil traces with our rag. When this is done, we lower the barrel to sit on the crankcase. We make sure the front piston is at its top dead centre by turning the motor and observing through the crankcase timing hole the vertical stroke on the flywheel. Another way is by looking into the front tappet block to watch the tappet rise and finally fall. As the engine needs to be turned, we place our hand on the barrel to stop it rising with the piston. We also need to watch the front inside tappet. This will rise and fall, indicating the piston is rising to its compression stroke. Once at the top, we let it rest. Before inserting the valves, we should first check their tolerances, their length and condition. We first check the face of the valve, examining for pits and burn marks. Our valve faces here are in good condition, but this is an indication of what can occur. This of course will need to be replaced. The matching seats and the valves should be examined now for cracks, pits and burn marks. If present, the valve seats may need to be reground or replaced. We need now to measure each valve stem. We measure its outside diameter and then the inside diameter of its valve guide. If the difference is greater than 1/4 thou, then the valve guide or the valve itself will need replacing. We now measure the valve's length by inserting the valve into its matching guide. We make sure the valve head is held hard against its corresponding seat. Only then can we measure its protrusion from the head. We sit the base of the vernier on top of the valve and lower the rod to the head. We can then read the measurement. If it exceeds 2.034 inches, then the valve may need replacing. Manufacturers normally supply a valve with a shorter stem. We suggest if these parts need attention, they should be taken to a reliable workshop. We certainly do not recommend shortening the valve stems with a grinder, as this removes the top's hardened surface. We're now ready to reassemble the head. We first insert the valve's spring retainer washer. This is followed by the valve stem seal. Using our seal punch and a hammer, we gently tap the seal down. Once the seal is properly seated, we can insert the valve, which we first dip in oil. Using a screwing motion, we push the valve stem through the seal. Ensure the valve is in its correct seat, because the valves are not retrievable without ruining the valve seals. Next, we slip on the double valve springs. These are followed by the retainer washer. Once again, using our valve spring compressor, we compress the springs. We apply the compressor as we did in disassembly. Using the compressor is a fiddly business. Once in position, we can compress the valve springs, making room for the collets. While inserting the collets, we must ensure that the thin edges face down. These tiny collets act as wedges that contain the spring and the valve components at high pressure. When the collets are correctly in position and evenly spaced, we can release the pressure on the spring by removing the spring compressor. All valve assemblies are carried out in this manner. After assembly, it's a good idea to test each of the valves. Tapping them with a soft hammer should provide enough stress on the valves to bring them apart if in fact they were going to give. We can now install the cylinder head by first placing the O-rings over the 2 dowels, followed by the new head gasket. The cylinder head, which is clearly marked front, is positioned on the barrel over its dowels. We then insert the 4 head bolts and torque them down in this sequence. Commencing with this bolt, we turn them a quarter turn at a time until all 4 bolts are torqued down to 7 foot-pounds. We then repeat the sequence until all bolts are torqued down to 14 foot-pounds. Having followed these procedures correctly, we mark the heads and bolts like this. These markings are a quarter turn apart. Using the same sequence as before, we again tighten each bolt until these marks line up. The rear head is installed in exactly the same way as you've just observed. We now replace the O-rings in the middle of the pushrod tubes by pulling the upper and lower pushrod covers apart. We simply slide the old O-ring off to make way for the new one. If the new O-ring doesn't fit snugly, then of course it's the wrong size. We then place the two large steel washers into the tappet blocks. These are followed by the new O-rings. We seat these with our fingers. We then replace the pushrod cover's top O-ring and insert the base of the cover into the tappet block. We do the same for the other pushrod cover. Before inserting the pushrods, check the balls on each end, making sure there is no pitting or scoring and that the rods themselves are straight. To check they are straight, roll them on a smooth surface. If a pushrod is damaged, make sure it is replaced with one of the correct colour code. We now insert the pushrods, bearing in mind that the front intake is yellow and the front exhaust green. The rear exhaust rod, by the way, is purple, while the rear intake is blue. Before putting the rockers and assemblies together, we first check the tolerances between the rocker arm bushes and their matching shafts. Using a vernier, measure the shaft's diameter at the spot where the two bushes in the rocker arms would sit. That is approximately 1 inch from each end of the shaft. Then measure each bush at each end of its rocker arm. If the differences between them is more than 3 thou, the bushes in the rocker arms will need to be replaced. Before reinserting the shaft, it is advisable to check the shafts for pits and gouges. If there are, the shafts themselves will need replacing. The pad at the end of the rocker extension on the rocker arms should be smooth, slightly rounded and free from pitting, otherwise servicing is recommended. The ball cup at the other end for the push rods should be smooth, rounded and also free from pitting. At this point, it's a good idea to clean the oil galleries with compressed air to remove any foreign matter. We now place the rocker and its shaft into position. In this instance, we're replacing the front inlet. With the indent on the rocker shaft facing the right hand or gear case side, we insert the shaft. We then face the indent to the outer side. Then push the shaft in till it sits flush. Taking our feeler gauge, we measure the rocker's end play by inserting the blade between the journal and the rocker arm while holding back the rocker arm. If the gap size exceeds 30 thou, the rocker arm and lower rocker plate may need to be replaced. We repeat these procedures for all rocker arms. Next, we place the smaller of the lower rocker cover gaskets on the head, followed by the larger of the two, being sure to use a reliable sealing compound on all the mating surfaces. We can then place the lower rocker cover, making sure that the rocker arms sit over the valves and that the push rods are seated in their cups. It may require a degree of manipulation before the rockers and push rods sit properly. After inserting all bolts correctly, they can be tightened down in the following sequence. These 4 half-inch bolts are tightened evenly in a cross pattern to 17 foot-pounds. Next, we screw down and tighten the 3 7/16 bolts to 12 foot-pounds. And finally, the 2 Allen key bolts. These too are torqued down to 12 foot-pounds. We then lay the middle rocker cover gasket into its recess, ensuring that it sits evenly all the way round. Once correctly in position, the middle cover is placed on next. This is then followed by the small centre gasket. We should ensure that this sits properly. Checking that the middle cover is evenly placed on the head, we replace the top cover gasket, making sure it sits down evenly into the recess. Finally, we install the top cover, placing it gently over the middle gaskets, being careful not to dislodge them. We need to ensure that the fibre washers have been placed beneath the steel washers on the 4 Allen head bolts. These Allen head bolts are tightened down in a cross-pattern sequence, eventually being torqued down to 14 foot-pounds. To complete the assembly of the front cylinder, we need to make sure that the hydraulic units have bled back any excess oil, and we do this by checking that the push rods can rotate. If they can't, try again in a few minutes. Because we're able to rotate our push rods, we'll complete the push rod covers assembly. We need to check the top O-rings are seated correctly to ensure an oil-tight seal. With our flat blade screwdriver, we raise the top cover, seating it in the head recess. To replace the push rod's retaining clips, place one end into the head and lever it in. The process is the same for all push rod covers. This now completes the assembly of the front cylinder. Before we can assemble the rear cylinder, we must, however, bring the rear conrod to the top of its compression stroke. We can now assemble the rear cylinder in the same way we assembled the front. Resting the stator on the shaft, we insert the plug into its recess, pushing it home with a blunt instrument. The stator is then bolted back into place with its 4 retaining bolts. We then replace the nylon retaining clip, being careful not to over-tighten the small screws. The spacer is then slid into position, followed by the rotor that is lined up and slid on the splines of the shaft. The rotor is then followed by the retaining washer. Normally the drive sprocket and compensating sprocket would be fitted now. Finally, we screw into place the locking nut. While working on this side of the motor, we can replace the timing inspection bung. We'll now replace the carby by sliding the inlet manifold flanges under the Allen head bolts. Supporting the manifold, we tighten all 4 Allen head bolts holding the manifold to the heads. We tighten these bolts to 12 foot-pounds. We then replace the top engine mount bracket and replace the washers on their studs. Next, we connect the earth wire from the VOES. We then replace and tighten both nuts to 18 foot-pounds. While working at the top of the motor, we'll replace the 2 spark plugs. The electrode gap for these plugs is between 38 to 43 thou. We'll now reassemble the electronic ignition, ensuring the nib and the rotor sits in this cutaway on the end of the cam. We replace the rotor and tighten its retaining bolt to 7 foot-pounds. We then replace the sensor plate by aligning it centrally over the retaining screw holes. Next, we replace and tighten the retaining screws, followed by the cover gasket. And finally, we replace and screw down the cover. Reassembling the electronic ignition in this way will enable the engine to run. However, the ignition will need to be dynamically timed. We have now completed the assembly of our Evo motor. The EasyJig engine stand used in this video is available through video manuals